All right, Algebra 2, this is Mr. Heeren. We're talking about 2.7, graphing linear inequalities and absolute value equations and inequalities. Graphing linear equalities is something you guys have seen before. Hopefully this is a little bit of review. Absolute value might be a little bit different for you though. So, if we take a look, inequalities have got to be the same way as linear equations except with a couple differences. Number one, if it is less than or greater than with no equals, then it's going to be a dotted line. And if it's got the greater than or equal to, less than or equal to, it's going to be a solid line. And the second part of that is there's got to be one part of it shaded. All right, you're either going to shade left or right, up or down, depending on what the line looks like. So if I graph 2x plus 3y greater than 6, well, right now it's not in a very good way to graph it. So I'm just going to do a little algebra here to make it easier to graph. So I get negative 2/3 x plus 2. So my graph starts at 2. I'm going to go down 2 over 3. It's going to be a dotted line. Now I got to figure out which way am I going to shade. Am I going to shade above the line, up and to the right, or am I going to shade below the line, down and to the left? So I'm going to test 0, 0. Why? Because 0, 0 is very, very easy. So if I put 0, 0 in here, and I can put it back in my original equation, I can put it in my slope-intercept form inequality. It doesn't matter which one. It's just which is it true or not. So if I put 0, 0 in here, is that statement true? Well, is 0 bigger than 6? No, it's not. So 0, 0 does not work. That tells me I'm going to shade away from there. So that tells me that I'm going to shade this area here. So if I'm looking this way, it's the same kind of idea. Well, let's use intercepts then. All right, so let's let x equal 0. And so if I do that, then 2y equals 4. So y is going to equal 2. So my y-intercept is going to be 0, 2. My x-intercept, where y equals 0, so that's a negative x equals 4. So x equals negative 4. So that's going to be negative 4 equals 0. Remember, when you use intercepts, even though it's an inequality, you pretend it's an equal sign. The end game is all you're trying to do is get a point. So you're allowed to do that. But remember that it is going to be an inequality when you build this. So if I got negative 4, 0, and I got 0, 2, it's going to be a dotted line. And I got to test 0, 0 to see if it works. So is negative 0 plus 2 times 0 greater than 4? Well, is 0 bigger than 4? The answer is nope. So I want to shade above. And if you want to shade it in or you just want to draw a couple arrows, I'm fine with that. So let's take a look. Manny has 15 bucks to spend at the fair. It costs $5 for admission, 75 cents for each ride ticket, 25 cents for each game ticket, right in inequality for the number of ride and game tickets he can buy. So $5 for admission, 75 cents for each ride ticket, 25 cents for each game ticket, right in inequality for the number of ride and game tickets he can buy. So if I let ride tickets be X and I let game tickets be Y, it costs $5 for admission. So out of the 15 bucks Manny already has, he's already down to 10. Okay, and the reason for that is that if I take 75 cents for each X, plus 25 cents for each Y, plus $5, it's got to be less than or equal to 15. It's less than because he can't spend more than 15 bucks. That's all the money he has. He can't spend more than that. So if I just subtract 5 quick, I'm left with this less than or equal to 10. So if I want to redraw that or rewrite that, I'm going to make it look like that. So what is the maximum number of ride tickets he can buy? So the ride ticket is X. So what I'm looking at is if I buy all ride tickets, I'm going to buy no game tickets. So it's like Y equals 0. So what I'm left with is how many ride tickets can I get less than or equal to 10? So I want to divide by 0.75. I want this one. So if I take this, if I take 10 divided by 0.75, I get 13 and a third for an answer. But what does that mean? So what that means is you can't buy 1/3 of a ticket, so that means the most you can buy is 13 tickets. So now flip it around. What's the maximum number of game tickets you can buy? Well, game tickets are 25 cents each, and that means he's not going to buy any ride tickets whatsoever. So it's going to be 0.75 times 0 plus 0.25y less than or equal to 10. So I'm basically dividing by 0.25 on both sides. So y is going to be less than or equal to 40. So we can buy 13 ride tickets, or you can buy 40 game tickets, or some combination thereof. Okay, so let's kind of do an absolute value. Let's take a look at absolute value again. What's inside absolute value with x shifts the vertex left to right. Remember, x inside the absolute value does the opposite of what you would think, okay? If it's addition, it moves left. If it's subtraction, it moves right. It's the opposite of what you would think, because in a graph, moving right is positive and moving left is negative, but it works backwards when you're talking about x. Y acts exactly how you think it should, okay? If it's addition, it moves up. If it's subtraction, it moves down. So if you want to look at this one, y equals absolute value of x plus 5 plus 7. The way you want to think about it is this. It's the equivalent of saying x minus h plus k, where h and k is your vertex. All right, so for this one, like x minus a negative 5 plus 7. So this kind of becomes h, this kind of becomes k. So that is the points of my vertex. That is the location of my vertex. So it's going to be negative 5, 7. So if I go x plus 1, absolute value of x plus 1 minus 2, here's kind of what it looks like. My vertex, remember, is going to be x minus negative 1 minus 2. So it's going to be negative 1, negative 2 is my vertex. So negative 1, negative 2 is right here. It's going to be just straight diagonal both directions. That's all that's going to be. That's all there is to it. Okay. Whatever this is, that's going to be what my vertex is. X minus something, then plus or minus on the outside. So x minus 4 plus 1. Remember, it's x minus h plus k. H and k are your vertex. All right, they're your ordered pair for your vertex. So in this case, this is 4, this is 1. So that becomes my vertex, 4, 1. It's the opposite of what you would think for the x value and exactly what you would think for the y value. There's your answer. Aha, let's see what the 2 is going to do in front of it. All right, so y greater than 2x minus 3. So this is like saying 2 absolute value x minus 0 minus 3. So my vertex is going to be at 0 and negative 3. What the 2 does is that it stretches it. Okay, so instead of the slope going up 1 over 1, it's now going to go up 2 over 1. So now, but look what else we've got. We've also got an inequality. So we're putting together a lot of pieces with this. All right, so what we're looking at is this. Let's start with the vertex. So we're at 0, negative 3. The 2 up front says I'm going to move it up. Instead of going straight diagonal, I'm going to go up 2 over 1. So that's what it's going to look like. The greater than, just greater than, tells me that this is going to be dotted. This is not going to be a solid line, okay? Kind of like with linear inequalities. It's not going to be a solid line there. And then much like inequality, I need to shade. But the difference is now I'm either shading inside or I'm shading outside. Everything out on the other side. So if I take 0 greater than 2 times the absolute value of 0 minus 3, once again, test 0, 0. If you can ever test 0, 0, do it just because it's easy. So I get 0 greater than negative 3. That's true. So I want to shade inside of here. So one tutoring company advertises specializing in helping students who have a combined SAT, verbal, and math score of 900 or less. Write an inequality to describe the combined scores of students who are prospective tutoring clients. Let X be the verbal, Y be the math. So basically, when you add the two together, you're supposed to get less than or equal to 900. That's who they help the most. So do you fit into that category if you've got a 480 verbal and a 410 math? Well, what is that? That's going to be 890. Yeah, that's less than 900. So let's take a look at this. Y less than absolute value of X plus 1. So it's like X minus 0 plus 1. So my vertex is going to be here. My vertex is going to be at 0, 1. I don't put anything in front, so I'm not trying to make it steeper. But it's going to be a dotted line straight out. Straight up 1 over 1. Slope of 1. So now this tells me that it's going to be dotted line. And once again, I want to test 0, 0. So I want to go 0 less than absolute value of 0 plus 1. So if 0 is less than 1, is that statement true? Yes, which means this is true, which means I'm shading outside of here. Okay, so I'm putting a lot of pieces together. Take it piece by piece, figure out the absolute value part of it, then figure out the inequality part of it, then figure out which way to shade. So let's take a look at this one on the calculator. So how do I do that? Well, first thing I'm going to do is go to y equals and clear that out. So I'm going to say 2. If I go to math, hit the math button, which is the third one down on the left. If I go over to num, you see where is this ABS there? That stands for absolute value of X minus 3. So what this says is exactly what my problem says, 2x minus 3. The only problem is that it's going to be a line where I want a dotted line. All right, so let's graph it. Let's take a look at where we're at. So there we are. So all this does is move it down 3. That's all it does. And that's kind of what we want. So now we know it should be a dotted line. We also know that the slope is going to be 2 over 1, so it's going to be steeper again. Now we got to figure out 0, 0. Is that going to work? So is 0 greater than 2 times 0 minus 3? Is 0 greater than negative 3? Yes. Shade inside. That's all I got. Please come talk to me if you have questions. And don't forget that the test is coming soon.